From a physical perspective, nothingness is a very complex and incomprehensible concept for our minds. This is the very same absolute vacuum that we already discussed when we were examining radio waves. The very same absolute vacuum that we talked about when we said that physics abhors emptiness and that any vacuum contains some amount of matter or fields or any other objects, and here we need to imagine nothingness. But honestly, I have to say, understanding this is even scary because we are used to the material world. We are used to physics working with substances, molecules, objects, and those kinds of things that we can touch. By the way, we had a very interesting video, check it out, where we discussed what matter is actually made of and what constitutes its smallest building block, which is quite relevant to the current topic. The video will be in the suggestions or via the link. So, since all our particles are material, and I repeat, material, in our case we need to imagine that such particles do not exist. Essentially, the theory of the universe stumbled because of the absolute vacuum. Since neither philosophers nor physicists could fully imagine absolute emptiness, and in physics, the rule that physics abhors a vacuum continued to hold true. By the way, a very correct rule. I seem to be speaking in tautologies today. A correct rule, but a very correct approach, that there is no emptiness, that there is no absolute vacuum. It was the inflaton field that was that very emptiness from which everything was composed. The inflaton field had a certain configuration. Like any quantum field, it followed this logic, or at least it is assumed to have followed this logic. We recently wrote about what a quantum field is in Telegram. Check out that note. I'll definitely leave a link. In short, a field, in its essence, is like a blanket, spread out across a room, held by the values of certain quantities. The description is probably not very clear. But in short, what is it? A field is a set of values. Where do the values come from? Imagine that in this room we took three quantities related to length. These are height, width, and length. And they took some quantities that correspond, say, to the temperature readings present at each point in this room. For example, over there in that corner, it's -5, let's say. Here somewhere it's +1, and over here it's +10, and so on. These values do not fluctuate significantly in the case of an ordinary room, but for understanding, this will be very important, and imagining it this way will be much easier. Now imagine that we have plotted these values in some graphical form. We have also placed this graphical form within these spatial coordinates, where we have combined the value of a point in the room, the geometric value of this point, its location, to be more precise, and we have combined it with the magnitude value that we have been investigating. When we examine this value, it is very easy for us to plot it in such a coordinate system. You remember the diagram in the same Word or in some other programs. In the same way, we can draw a room, and once we have mapped the temperature in this room onto these columns, we can already connect this temperature with some kind of covering or link it together. And if in the two-dimensional space we map the temperature on these columns, then we can already connect it to tie the temperature with something like a blanket or connect it. And if we are in a two-dimensional space, then points that repeat on the graph one after another, simply connecting some lines, will form not a line but a certain plane in space. And what is a configuration? It is a set of certain values. So if in the case of temperature we only have the temperature value, then in the case of more complex fields we can have some complex values. That is, at one point there can be multiple values simultaneously. For example, the values of temperature, humidity, and pressure. These values will also vary, and this set of values will create a configuration. I hope this is more or less clear. We have an inflaton field. The field has a certain configuration, and, according to the existing quantum theory, any particle can appear from a field, well, just like that, unexpectedly, because certain parameters aligned, because some fluctuation occurred, and the field generated a particle. Again, there is a very good illustration showing what, according to quantum physics, electrons and other subatomic particles actually are, and they are represented as field fluctuations. This field fluctuation could also occur in the inflaton field under certain conditions. Such disturbances in any phantom field can appear, disappear, and reappear, and this is how everything can happen. In the case of the inflaton field, it works the same way. It is worth noting that the physicists have taken some precautions here and have stated that the inflaton field did not appear out of nowhere and that there was likely some information involved. And perhaps this information contained records, like some kind of registry or program code, or the same matrix that we often refer to, because it is a quite fitting example for our topics. At some point, such a fluctuation may occur, and a particle or quantum from the inflaton field may appear. This particle was named inflaton. As you might have guessed, similar to the inflaton field, the inflaton itself is a hypothetical particle that no one has ever found, no one has ever seen, and most likely no one ever will. Nevertheless, we can hypothesize its existence and thereby add to our collection of hypothetical particles. According to the existing understanding of the inflaton field, the inflaton began to alter the field that exists around it. It started to organize it. There was a sharp reconfiguration of this field. As a result, the potential energy in the area where the inflaton exists began to decrease, while the kinetic energy started to increase, leading to oscillations in this field. This is because a new particle, which is an energetic oscillation of this field, has emerged. After the emergence of such a particle and the attempt to organize all of this, the resulting large amount of kinetic energy led to what? Well, bravo! You probably already guessed it. The Big Bang. The very Big Bang that, in fact, created the particles we studied in the video above. And so, after the Big Bang, the most incredible and interesting particles poured out like a cornucopia,